Let's take a look at the two-sample t-test and the confidence interval that goes with that. The t-test is typically used for numerical data, and so we'll be analyzing means. The claim that we typically would test in this situation is there a significant difference in two means of two different independent groups? We're going to load the normal packages, and the example that we're going to work on here today is in this electric cars data set. So there are 122,000 different electric vehicles. Some of them receive this eligibility because their battery charges can last several hundred miles. And the government will give a tax return to those electric cars that have a battery life that is long. So for example, they would give the eligibility rating to cars that are strictly run by the battery electric vehicles, and maybe they wouldn't give a tax return for the other kind of electric vehicle, which is the hybrid, where it's plugged in, and vehicles typically like that have a lower battery range because the gas engine then picks up after a while. So it makes sense to think that those that receive the clean car designation, clean electric vehicle designation, will have longer mileage ranges on them than those hybrids. So that's the claim we're going to test. We're going to load in this data set from Washington State on electric cars. Let's take again a glimpse at this, and you can see all the 17 variables, VIN number, and so on. We're going to be looking at the two alternatives for clean alternative fuel vehicle eligibility, and we're also going to be looking at the electric range. This is the range the car can go on one battery charge. Notice these are numerical data values. They are doubles, and so therefore we can take the average and standard deviation, so on. So what we're going to do is we're going to split those numbers up into two groups: those that receive the clean fuel eligibility rating and those that do not. All right, I'm going to create a couple of temporary copies of the electric cars in there. And then the first duplicate copy, I should say, is X. So what we're going to do is we're going to add this new field called clean fuel eligibility. And there are three different responses in the clean alternative fuel eligibility category. The variable we're going to take a look at here is this qualitative variable, and it's got three different levels. And you can see those three different levels here. The two that we're interested in is that the vehicle is either eligible or it's not eligible because of a low battery range. This one here in the middle is the third response, but we don't know if those cars are eligible or not. And so therefore, we're just going to get rid of all those and just compare the eligible ones to the non-eligible ones. So let's take a look at the table of this variable. And there you can see most of them are eligible. Well, I say that. That's the plurality of the three categories. And we're going to get rid of this one right here. And so you can see we still have about 75,000 cars, many of which are eligible and others that are not eligible. So we're going to create this new variable, and we're going to combine the three categories down into two. We're going to assign false because these cars we don't know, so they're not eligible. And these are definitely not eligible because of the low battery range. The only ones that are eligible are the 59,000 here. So we're going to assign those true, those are eligible, and the other two categories we're going to assign false by using this assignment statement here. Okay, so we've changed the clean fuel eligible variable there. You can see that now it has just two categories, the trues and the falses. Here were our trues, the cars that are eligible, and these are the combination of the two frequencies from the other category. So we're going to do a little bit of exploratory data analysis here. And the first one we're going to create is this frame called X1, and it's going to contain only the trues. These cars are the ones that are eligible. So we're going to get some summary statistics on the eligible cars. And there are some data values in there where the range of the battery is said to be 0, which in that case, it's probably a missing data value. So let's take a look. Here's the 5-number summary and the mean. In there, you can see that the smallest range is 30, and that one was declared to be eligible for the clean energy discount. And the largest battery range is 337 miles. We are then going to group all the falses together. Those are the ones that are not eligible. Again, we're going to ignore the ones with ranges of none. They're all supposed to have a range because they all have batteries of some sort. So we're going to ignore the ones that have an electric range of 0. And here's what we see. Now notice that the max on this one goes up to 29 miles. So that must mean that's the cutoff. So if you have 30, if your battery can last 30 miles or longer, you're given the eligibility. And if it's less than 30, you're not given the eligibility. So the minimum value, once we take out all the zeros, is a battery that has a range of about 6 miles. All right, let's take a look at the mean and the standard deviation and the sample size, because if we're running the test and we're comparing two groups, we need the mean, the standard deviation, and the sample size of each group. So the first one we're going to do, X1, are our trues. And what is the average? Well, we already know because there it is, but we'll calculate it once again. All right, 162.5. The standard deviation of the same group is 89.9. And then we already know we have close to 60,000. Notice the code here. We do the dimension, and the dimension gives us the number of rows first and then the number of columns. And if we just want the number of rows, we just put the number 1 there in that spot. And you can see our 59,000. And then we're going to do the same thing for the second group. Remember, the second group is the group of cars that are not eligible for the clean vehicle discount. And notice the mean on this one is only 19.4. So there's a huge difference in the means between those that are eligible and those that are not eligible for the clean car discount. Here's the standard deviation, much smaller because the range is much smaller. And then again, if you want the sample size, notice here it only gave us the 15,000 number because we're comparing those that do have the discount to those that don't, and we're eliminating the ones that we don't know. Looking at the means, we have 19 or 19 and a half here for the one group, and we have something much, much larger, 162 for the other group. And so there's a 140-mile difference in the averages between those two groups, and that's huge. Another thing we like to do when we're doing some exploratory data analysis and we're comparing two numerical data sets is to construct a multiple box plot. Now for this one, I don't want to include the nose. And now, so I just created a couple of frames before, but I need to create a new one because I want to have all of our records there, and I want to filter it down just into our two groups. So we're going to get rid of all of the cars where we don't know if they're eligible or not. And we can do that here. We're going to create a new frame Y1, and it's only going to contain the clean alternative fuel vehicle eligible and not eligible. And we're going to get rid of that middle category. Now what we want to do is we want to, once again, we've done this same command early on, but here it's just creating this new frame Y1 that has just the two classifications, and we're going to get rid of all of the unknowns. So if we take a glimpse, you can see here that we now have our clean fuel eligible variable, and we have trues and falses only. So now that we have just those two choices for the two outcomes we're interested in, we can draw a multiple box plot of the data. And notice the X is going to be our categories, the true or false. So we're going to see two different box plots in comparison. And what we're measuring, the Y variable, would be all of those numbers, all of those battery ranges of all the cars. And just remember, these box plots are going to look quite different because the average of the one is 162 and the average of the other is 19. And so you're going to see a huge vertical shift between these two graphs. Let's take a look. ggplot box plot command. And notice I have a couple of titles on there to make it pretty. And here it is. Looks like my title's a little too long, so I'll have to go back and fix that. Here's the range in miles. And notice right about here is this is the median. So notice the median's much higher than the mean, which is down in here somewhere. And then you can see all of these other cars, they range from about 0 to 29. So it's a small range in here for these non-eligible cars, and a much larger range. This one begins at 30 and goes up. So always try to visualize, create a visualization for your reader. So we've observed some major differences in these two groups in their means. And the mean we're looking at is the average battery range of these electric vehicles. Noticed a huge difference. And the test that we run to decide if that difference we observed is statistically significant is called the t-test. Now we're doing a 2-sample t-test because we are using 2 different groups. And the 2 different variables that we're using from our Y frame is electric range. That's the numerical variable. And then the second one that you list is the categorical variable with the 2 outcomes, true and false. We want a less than because this test always reports the falses first. So the first group is the falses and the second group is the trues. All right, so I want to use the Y1 frame that I just used, and down in my function here, I'm using Y, and so I'm going to make this assignment statement, and then I'm going to run the t-test, and you can see here that our 2 variables are the electric range. It's the numerical variable that comes first, followed by the tilde, and then the categorical variable. And then we're going to do a alternative hypothesis to be less than, and we're using less because it always reports the falses first. We've got our data frame here, and then here are what we get for the results. Tells you what test is being run, the t-test, 2-sample t-test. Here are the 2 data values. Gives us the test statistic and the degrees of freedom. And I think this is an error because it's giving this to us all the time, but no worries because we're going to parse out these results one at a time in just a second. So the alternate hypothesis, since the p-value is so small, is true, they say, and so there is a difference in the means. Take a look at what that difference is. The confidence interval we're not going to do a whole lot with for non-two-tailed tests. And then here you see the mean for the false group and the mean for the large group. And so the first group is less than the second group is what our alternative hypothesis is. All right, I'm going to parse these out one at a time. So you got the results up here, and then you just put the little square brackets after it, and it reports each of these results. The first one that it reports is the test statistic, and then it gives you the degrees of freedom, and then it gives you the p-value. And notice that p-value is different than the output up here. So I think this one here looks like it's stuck on 2.2 times 10 to the negative 6. But this relationship is so strong that it just tells you that the p-value is 0. And here's our confidence interval that we're going to ignore for this test. And then if you want the lower bound and the upper bound, it'll give you those as well. Results 5 gives you both of the means. And then if you go to estimate 1 and estimate 2, it gives you the individual means separately. In spot 6 of results, it tells you what the null hypothesis is, and that is the difference of the 2 means. Mu1 minus mu2 is 0. And if you do a little bit of algebra, then that means mu1 is equal to mu2. Gives you the standard error of the test, tells you what alternative hypothesis you selected, gives you the name of the test, and then the data variables that you are using. Okay, so in summary, we have a huge difference between the means. Our p-value is essentially 0. So when that happens, we reject the null hypothesis. So in this test, we have 2 hypotheses as usual. The null hypothesis is a statement that there is no difference between the 2 means. Mu1 and mu2 are equal. And if you clearly define the variables, and this is important because it tells you what data to go look for, you have mu2 is the mean battery range of the clean cars, of the eligible cars. And mu1, because it always gives falses first, is the mean range of the non-eligible cars, the hybrids mostly. And if we reject this null hypothesis, we're rejecting it in favor of the alternative that says that one is less than the one mean is less than the other. And this is the mean of the false. These are the ineligible ones, and these are the eligible ones. So the eligible ones are larger than the ineligible ones. And that's what we say here in language. In words, we're saying pretty much the same alternative hypothesis, that the clean alternative fuel vehicle designated cars have a higher average battery mileage range than cars without that designation. And so our conclusion is to reject the null hypothesis in favor of the alternative because p is less than alpha. So the first mean is less than the second. And then in conclusion, we say that there is evidence that the mean battery mileage range of cars that are clean alternative fuel vehicle eligible, and those that are not designated or eligible. There definitely is a difference, and the evidence suggests that the clean alternative fuel designated cars have a higher average battery mileage range than cars without the designation. Now, this test also gives us the confidence interval. So if you're going to do a confidence interval in this situation, you'd use the same function up here, the t-test, and then you'd specify your two group. We're not going to do a confidence interval because it's not a two-tailed test, but if we were to do a confidence interval, we would be estimating the difference between the two population means. And if the difference between the two population means is positive, positive, then we're estimating mu1 minus mu2 to be positive. And that means mu1 is greater than mu2. You could get a negative negative confidence interval or a negative positive. And just like the difference in two proportions, we interpret the confidence interval in a similar way. The command that gives us the confidence interval is here. And because it's a one-tailed test, it's going to give us infinity on one side or the other. Okay, so this is just one example of the two-sample sign test.